All right, so let's go ahead and go over our review sheet. So again, I'd highly suggest doing this first so that you kind of know what you know and don't know on here. So at top, there's some vocab on here. You did make that little group research thing with the solution self-discovery, so a lot of those words are in there. The one that I won't be asking about is Henry's Law, because with the shortened time, we really didn't have time to get over that. It just says that solubility increases with pressure, but it won't be on here. There is one question on here, though, about it. Won't be on the test, though. All right, so you're asked 3 things you can do to speed up the salivation process. So think about making something like Jello or sweet tea, what you would do. The best thing you can do is increase temperature. We've seen in the solubility graphs that for most substances, besides gases, that solubility increases by heating it with it. So you could heat it up. So using something like hot water to make your sweet tea or your Jello is what you do. You can stir it, agitate it, mix it, any kind of word along with that. So that's going to give them more kinetic energy. They're moving around more. That's going to be easy for them to get in those open spots where they can dissolve. The other thing you could do is increase surface area, which means either decrease the particle size or crush it. So something like the sugar that you cook with is easier to dissolve in tea than the bigger chunks, or when you buy Jello or things like that, they're powders to mix those in. All right, so our next part is our solubility curve, which is like the graphs that we did last week. So you just have to match up whatever they're looking for in here to help you find your answer. So on this first one, it wants to find the solubility of NaClO2. So we want to make sure first we're using this line right here. And then the second thing is we have to match up what they asked us about. So we want to know when it's 200. So we're going to go over on here, and then we're going to see where that hits the curve here. And that's pretty close to the 80 line on here. We don't have a great graph on this in numbers with that on there, but it's pretty close to being right at 80. Okay, what's the solubility of KNO3 potassium nitrate at 30 degrees? So we need to find our KNO3 line here, which is this one right here. And then we want to figure out what it is at 30 degrees. So this time we're going to have to estimate a little bit and then come over here. And then we're going to see on here where 30 hits that line on here. And when we do that on there, we see it's between the 40 and 60. So I just estimated about 50. If there were more markings, we could get a better line, but it was somewhere between 40 and 60. So I just said about that. Now notice on the solubility, I did put per 100 grams of water. So the solubility should really include, per that is usually 100 grams of water. All right, so on the potassium nitrate on here, it asks how many more grams would dissolve there. So it's talking about problem B. So we already know it can hold this. And it's saying that we've already put in 22.0. So you just subtract those on there, and you could add 28 grams more. So D asked us to look at increasing solubility at 50 degrees. So we just had to come over to 50 here and see which line hit first. So the lowest line on here would be NaCl. It's got the lowest number. Then KBr, then the KNO3, and then finally the NaClO2. So just be able to read the graph and look for any of these things. On E, it asks us potassium bromide at 80 degrees is 130 grams are dissolved, and what type it is in there. So if we looked at 80 degrees here on this, we're going to go up to this KBr point on there. And at that KBr point at 80 on there, we can see it's a little less than 100. It's like probably 90 some. On there. So it's way over that. It's 130. So that's super saturated. So again, they had to do that by getting it dissolved at a higher temperature and then cooling it. What would happen if I added more KBr? It would all crystallize. We saw that sodium acetate video and how it all just started crystallizing. Anything super saturated would go like that. Now, if our solution was saturated, it would sink to the bottom, and if it was unsaturated, it would dissolve. Okay, so how can I change pressure to increase solubility? I would increase, and again, don't worry about that. It won't be on the test, but I didn't change it at that point. So your next point, you're asked to do this. Now, this is a liquid thing. So usually it's like powder and water is almost always the solvent. But if I have 2 different substances, the one that's in the lesser amount is going to be your solute and go on the top. And then remember on these, it's a whole solution on percent solutions. So your solute here, there's 43.2 milliliters of ethanol compared to the 75 of acetone. So that would be the ethanol, and then the solvent would be the acetone. So percent by volume, we're going to take the volume of the solute, which is right here, 43.2. And then on bottom, we need to add both of these together. So if you add 43.2 and 75, that's 118.2. Divide those two numbers, and don't forget to write your times 100. And that would be 36.5 for your ethanol. Now in percent by mass on here, very similar, except for you want to use the grams instead that they gave you. So in this one we have 36.12, and then the other one is 82. So on top would be the 36.12, on bottom we add those two together, so that's 88.12. Divide those on there, and it's 41.0% ethanol. So again, if you look at those numbers, you can tell it's a little bit less than half, so that answer makes sense on both of those. All right, so our next problems on here, we're looking at some of our math equations. So the first thing is if you're doing molarity or molality, and you want moles, and you want to make sure you're using the number that's just the solute. So what I know here is that I have 50 grams of calcium nitrate, but I need to make sure then I know how to write that formula. So calcium, I know, is in the 2 plus column. Nitrate, I see, does not end in IDE, so it's a polyatomic. So I need to crisscross those. So that 2 is going to come over here, and that's just a 1. So my formula is CaNO3, 2. Now, unfortunately, if you didn't get that formula correct, that's going to throw everything else off, so you have to be careful for that. Molar mass of that, I'm going to add up 1 calcium, that's 40.08. Nitrogen is 14.01, and then oxygen is 16.00. So what I did is I added the 14.01 to the 16.01, and then I doubled that because that 2 goes to both of those, and then I added the 40.08. That molar mass then is 164.10. So in my calculator, I'm going to take my given number, 50.0, and then I'm going to divide it by the 164.10 that's on the bottom, keep 3 sig figs, my starting number, 0.305 moles. So molarity is the moles of solutes. So that's going to go here. That also means in our molality problem, we're going to see that same number go there as well. So I plugged it in 0.305. Then I also need the whole solution. So I want to make sure in this one, I'm going to use that whole number, and then I'm going to move it back 3 spots. So 0.258, I could have put no in there too, but it's still 3 sig figs. Divide that out, and then my solution is 1.18. And then make sure your label on this is the capital M for molarity. Now I'm doing it. Percent by mass would be the gram. So we already figured that out earlier, 50.0. And then for the whole solution on here, you can't use the volume of solution here because it's not water. If we knew the density, we could use that, but we don't. So we're going to take 250.0, so that's our solvent, and then that's milliliters. We need to get that to grams. Water has a density 1, so 250.0. Move it back 3 spots, so 0.25 on there, on kilograms on there, and again, just the solvent for molality. So your solution is 1.22. Your label is the little cursive M or italicized M. For D, now we have a dilution problem, so don't forget about M1, V1 is M2, V2. So what volume of the original solution? That means we don't know V1. M1 we found in part A, it's 1.18. M2 we know, 0.050. And then V2 is 20.0. Now notice this new solution is very weak to compare to the original one in there. It's 1.18, and it's going down all the way to 0.05. So that on there is like a 20th or so as much. So we know our answer should be really small, like less than 1 milliliter, since we're changing the molarity so much. So in my calculator, 0.050 times 0.200.0 divided by 1.18, and we get 0.85 milliliters. So again, our strength is around a 20th, so our volume should be around a 20th. So that hits right in there. And again, the first one was milliliters, so our label is milliliters. All right, last thing, something we've been spending a lot of time on, net ionic. So I have to break apart anything that is AQ. So on this one, the states are already given. So I know in this reaction, if I'm doing this right, I have to be making this, and that should be made of an aluminum and a phosphate ion since it's aluminum phosphate, or phosphate. On the first one, I see in parentheses there, so that's a polyatomic. And again, if you don't remember ammonium's charge, you can go to your polyatomic list. Notice here there's this little 3. So that means down here I need to put that 3 in front. So that'll break apart into 3 ammonium ions, and then PO4 has a 3 minus charge. That's why we see that 3 there. So if I was going to draw this, what it would look like with cards, you would have had 3 of the +1 cards and then 1 of the 3 minus. So when I break that apart, I should see that as well. 3 positive cards and 1 3 minus card. Aluminum bromide, 3 is the charge of Al. That's why Br gets a 3. So Al3 plus and then 3 Br minus. Bromine's a halogen, so -1. AlPO4, don't take apart. It's a solid. That's what you're making. There are 3 sets of ammonium bromide, so 3 NH4 pluses and 3 Br minus. So we're going to cancel those out, the things that shouldn't be here. So NH4 plus and NH4 plus. Ammonium is always soluble, so it's always going to cancel out. Phosphate's in the compound, can't cancel it out. Aluminum's in the compound, can't cancel it out. And then most halogens will cancel out unless it's with the 3 exceptions. So write what's left, PO4 3 minus plus Al with the 3 plus charge makes AlPO4, and again the ion should be AQ, and the S is for the solid precipitate. If you don't like the way that looks and you want to write Al3 plus PO4 3 minus, some people like to write it that way because they're used to seeing the metal and then the non-metal or the polyatomics. So this time it did ask you for the spectator, so that's just what you canceled out, the ammoniums and the bromides. We won't always ask you for those. All right, so one more of these, except for this time you had to come up with the formulas yourself. So lithium carbonate, Li is a alkali metal +1. Carbonate we see does not end in IDE, so we're going to go to our blue sheet. So CO3 2 minus, but don't forget you have to crisscross those two. So Li2CO3. Aqueous, it's got an alkali metal in it, and the ones on the left always have to be. Strontium is in the second column, the alkaline earth metals, so 2 plus, and then nitrate's a polyatomic, NO3 minus, so crisscross those, SrNO3 2. On the right side, we're doing double replacement here, so that means you know you're going to have to put the outer 2 and the inner 2 together, making sure to write the positive elements first. So Li goes with NO3, Li is plus, first column, NO3 is minus, so you get LiNO3, but on the left you have 2 lithiums and 2 nitrates, so that's why I put a 2 there. On the right, you're putting strontium, which is 2 plus, with carbonate, which is 2 minus. Those are going to cancel out, SrCO3. And on the carbonate rules, a lot of carbonates are precipitates with a few exceptions. This is not one, so that's your solid, that's your precipitate. Break everything apart, 2Li plus CO3 2 minus plus SR2 plus 2 NO3 minuses. So again, the left side, everything should break apart. On the right side, break apart your AQ, so 2Li plus, because it's first column, plus 2 NO3 minus. Keep SrCO3 together, it's your precipitate, and again, you should be making this in your net ionic. So alkali metals always cancel out, and so do the nitrates. What's left? The CO3 2 minus plus SR2 plus makes the SrCO3 solid, and again, if you want to write strontium first, that's fine. And then just say what you canceled out. All right, so for Thursday, we'll be doing our multiple choice quiz, maybe a few other problems. I got to kind of see what I have out there and what I feel like is going to work best for you guys. So you need to know some of the vocab, know words like solvent, solution, know what AQ and S states mean on the solubility rules and that sort of thing. Math-wise, you should see molarity, molality, percent solutions, and dilution equations. Remember, I might also give you one with the water added where you have that extra step. Watch out for units, like have to be in liters, have to be in kilograms, and remember water's density is 1. And then net ionic will be on there too. So again, just know you should be making that precipitate, and it's got to make sense what you have. I don't want to see like aluminum plus nitrate makes aluminum phosphate. That wouldn't make sense on there. You've got to make sure things go together that would. And again, you know things like salt or aqueous, so I should never see things like sodium and chlorine making salt because that's not a precipitate. You should be able to identify the spectators and the overall reaction. Okay, so let me know if you need anything. And again, this shouldn't be too hard. With it, you just need to know the basics and be able to plug it in. Again, be prepared with your calculator, with a periodic table. If you don't have one, then at home on there, then print one out, or find one somewhere that you can use, and something else like a book or something, or another device or whatnot. You will be timed, so again, you're not gonna have time to go look all these things up. If you run out of time, you're just not gonna get credit for the ones you didn't do, and you don't want that to happen for it. But again, it shouldn't be anything that's really an issue unless you're looking things up or whatever that you wouldn't have time for. So again, just do the best you can, and we're going to be compassionate to you on how things go, whatever this unit, and we'll see what happens the rest of the year. Okay, so Canvas message me or email me if you have any questions. One thing we might consider is doing a Zoom session. We'll have to see how that goes. I might throw up a PowerPoint or something with the key with some extra practice problems too. And then we'll start fresh after these next 3 classes on there. The 2 units we have left are gas laws and acid and base, so I need to talk with the other chemistry teachers and kind of think what we're thinking. And, honestly, right now, no one knows if there's going to be finals or anything, so we're just going to do the best we can and teach you the highlights, and I wish we could be in the lab and do another fun stuff with you, but we'll just do the best we can. Take care, and hope you got through this okay, and if you didn't, please ask me or somebody else for help. Bye.